the maximum theoretical range at which aircraft at flight level 230 may receive from VOR facilities sited at mean sea level. So the formula for the theoretical range is 1.25 into h1 square root plus h2. So substitute the values 1.25 square root of h1. In place of h1, you have to put the flight level of your aircraft, which is 23,000. At h2, the position, that is the vertical distance of VOR facility. So it is stated that VOR is at mean sea level. So we can put it 0. So 1.25 into square root of 23,000. So square root of 23,000 is, using your scientific calculator, 151.6 or 152. So 1.25 into this will give you a distance of 189.5 nautical miles, which is approximately 190 nautical miles. So select option A. Okay, in some formulae there is 1.23 instead of 1.25. Never mind. You get approximately similar answer. Let's go to question 42. Aircraft flies along a VOR radial. It will follow what? So I have said this so many times. We have VOR stations and we have radials emanating from this VOR station. Now when you fly along a particular radial, let's say radial 090, you will fly outbound. You will fly outbound from a VOR. You will fly outbound from a VOR. So whenever you talk about radials, radials means outbound. The job of radial is to take you outbound. If you want to fly inbound, that is towards the VOR, we call it course. We call it course. Meaning, you can fly towards this VOR following the same radial 090, but in that case, you will say you're flying a course, right? Your course of 270. In that case, if you're flying inbound. Flying outbound, it will be called radial 090. So remember this word, radial, excuse me, radial outbound, course inbound. So the correct option here will be, you will be flying a great circle track. Another important thing, all radials are great circles. Okay, VOR radials are great circles. Next, question 43. An aircraft is at 6,400 feet. VOR is at 160 feet. What will be the range? So range is equal to 1.25 square root of h1 plus h2. 1.25, substitute the values in place of h1 6,400, for h2 160. So 1.25 into square root of 6,400 is equal to 80. Square root of 160 will be 12.6 or 13. So 1.25 into 93 is 116.25. So approximately 116 nautical mile, or the closest here is delta, 120 nautical miles. So select option 120. Question 44. VOR and NDB are co-located. Aeroplane has an RMI in it. And the radial is 090. What will happen to magnetic variation? So that means, diagram wise, here is your VOR and NDB co-located, and you are on radial of 090. You are on radial of 090, flying inbound, flying outbound, whatever. Now, what will happen to the variation? Now, I have said this so many times before. In case of VOR, in case of VOR, variation is to be applied at VOR station. In case of NDB, variation is to be applied at aircraft. At aircraft. Why? Because all radials originate from a VOR station, so that directions are determined at the VOR station itself. But in case of NDB, NDB sends an omnidirectional signal. Now the direction from where that signal is coming is determined by aircraft receiver, the sense aerial and loop aerial. Okay, so that thing happens at aircraft. Okay, not on the ground at NDB station. That's why in case of VOR apply variation at VOR station. In case of NDB apply the variation of aircraft. Now aircraft will be flying, it will not remain stationary at one position. So it can fly outbound like this, it can fly inbound. So as it flies from one place to another place, the variation will keep changing depending place to place. The variation of aircraft keeps changing. In order to obtain a relative bearing of an NDB station, you will have to continuously keep updating your variation. The system does that automatically. But theoretically, you must remember that VOR variation to be applied at VOR, NDB variation to be applied at aircraft. The only thing is that in case of NDB, since variation is applied at aircraft, the variation will keep on changing and therefore the direction will keep on changing accordingly with the variation. So the ADF needle will not move, that is wrong. The VOR needle will not move, but the ADF needle will change, yes. Both VOR and ADF needle will move, wrong. Neither the VOR nor the ADF. So correct option is bravo. The VOR needle will not move because VOR is fixed to the ground, so its variation is going to be remain fixed. But in case of ADF, what happens? Variation at aircraft will move or change as aircraft travels from one place to another place. And accordingly, the ADF needle, the relative bearing indicator, will keep on changing according to the variation change. So let's go to question 45. There is a VOR and NDB co-located. An airplane with an RBI relative bearing is flying away from both locations on a radial of 090. The variation is changing rapidly. What will happen? Okay, now again, same question, similar question. The VOR needle will not move. Yes. ADF needle will move as the variation changes. So correct option is option A. I don't even have to look at next options, but we will check it. ADF needle will not move, so option bravo wrong. ADF needle will move because variation is also changing rapidly. Both needles will move, wrong. Neither of them will move, that is also wrong. So A will be the correct option, remember. Question 46. An airplane on a heading of 180 is on a bearing of 270 degree magnetic from VOR. From a VOR, that means the QDR is 270 and QDR is nothing but your radial, correct? QDR is your radial. Now you have to find bearing to the VOR that should be selected on OBS, okay, in order to get a true indication. Now you want to select a bearing to the VOR. So bearing to the VOR is called QDM, and QDM will be reciprocal of QDR 270, which will be 090. So if you want to go towards the VOR, you will make a setting of 090 in your OBS. If you want to go away from the VOR following a radial, you will select a setting of 270. So the correct option will be option A. Okay, so read the question and accordingly mark the answer. 47. An airplane flying on a heading of 180 is on a bearing of 270 degree magnetic from VOR. So that means QDR, nothing but your radial, is 270. The bearing from the VOR that should be selected on OBS. So similar to the previous question, but here you have to select bearing from the VOR and not to the VOR. So if you want to go from the VOR, away from the VOR, on this radial 270, you will select what setting? 270 itself, right? If you want to go away from the VOR. Diagram wise, I will draw it. This is your VOR station. This is your radial 270. This is your radial 090. Now, if you want to go outbound on radial 270, an OBS setting of 270 here with a from indication will be achieved. And in case you fly inbound, OBS setting of 090 to indication. Okay, so now here you are going from, so 270. Next question. An aircraft at flight level 100, 10,000 feet, VOR at 100 feet, what should be the range? So use the formula range is equal to 1.25 square root of h1 square root of h2. So h1 is 10,000, h2 is 100. So 1.25, 10,000 square root is 100 and 100 square root is 10. So 1.25 multiplied by 110, 137.5. So the correct answer will be, better to select option A, 135 nautical miles. Okay. So yeah, that's how you do it. Let's go to the next question. Question 49. The maximum theoretical range at which aircraft at flight level 210, 21,000 feet may receive signals from VOR 340 feet is what? So same thing, range is 1.25 square root of 340 plus square root of 21,000. So 1.25 square root of 340 will be 18. Square root of 21,000 will be 145. Add both of them. 163. So you get an answer of 204 nautical miles. Okay. So correct option will be delta. Let's go to last question for the day. Question 15. In which frequency band do VOR transmitters operate? That band is called VHF band, between the frequencies of 108 megahertz to 117.95 megahertz. Out of this total band, the range between 108 to 112 megahertz approximately is shared with ILS localizer, in which, how is the bifurcation done? The frequencies with odd decimals are given to localizer, frequencies with even decimals are given to VOR. Okay, remember this. VHF band, odd decimals, localizer, even decimals, VOR. Only and only between the range of 108 to 112. After 112, beyond 112 megahertz, that is beyond 112 up to 117.95, all frequencies are exclusively available to VOR. Odd decimals as well as even decimals. Remember that point. So with this, we have come to the end of this lecture. I hope you have understood all the 10 questions we have done today.